Okay, guys, video number 2 for 6996. You know, my goal here is, well, one of my goals is this, because this stuff is such dry material, is to keep you from going to sleep. You know, I wish I was creative and entertaining and all that stuff, but I can't sing, can't dance, so just bear with me. I'll try to get through these as quickly as possible. But what I want you to do, the whole time you're watching this, there's a method to the madness. I've been through this, and I've not only been through it myself, I've been through it with students that I've advised on. Actually, I've never advised a master's thesis, but I've been through, I think, 4 or 5 dissertation advisors. So keep in mind that, when you watch this stuff, again, there's a method to the madness. There's a framework I'm trying to develop. Also keep in mind, by the end of the semester, you guys need to have your master's thesis proposal completed. So, you know, throughout the time of watching these videos, keep in mind ideas for potential research. Now, the research ideally is something that's geared toward improving instruction, improving programs. You know, improvement is broadly I guess, well, it's broadly inferred. So you know, just keep that in mind as you watch this, and when it gets dry and you want to go to sleep and stuff like that. Think all the time, what can I get from this that's going to help me develop a master's thesis proposal and topic. This video's just kind of setting the framework, the foundation for video 3. So guys, let's go for it. In talking about the scientific approach, the foundation comes from evaluating deductive and inductive reasoning. Last thing I want to do to you, for you, with you, is sit here and read these PowerPoints. So I'm going to highlight some things that I think are important. Deductive reasoning, introduced by Aristotle many years ago. It's described as going from the general to a specific knowledge through logical argument. You know, deductive reasoning can organize what we know. It can identify new relationships, but deductive reasoning cannot create new knowledge. Now, you know, in the scientific approach, in your master's thesis, we ultimately are going to be seeking to create new knowledge to our field. On the other hand, inductive reasoning, introduced by Bacon in the 1600s, it still seems kind of weird to me that someone would challenge Aristotle, but Bacon did, and you know, he felt firmly that you should not accept the word of the authorities as absolute truth. That knowledge and is kind of a continuous process of inquiring and you know, conducting studies, and you know, we may know something, but do we really know it? Well, let's conduct related studies and see if we can enhance what we know, or maybe in some cases you find out that what you thought was knowledge wasn't. So guys, deductive reasoning takes a look at, observes events and makes inferences. Now, that's almost ideally the definition of conducting a study of inferential statistics. So you should be able to make that connection now. Examples of deductive reasoning: every mammal has lungs. So we've made statement about mammals. All rabbits are mammals, so every rabbit has lungs. Inductive, just opposite. There's an observation. So every rabbit that we have seen has lungs. Therefore, we make the conclusion that every rabbit has lungs. So I don't know why I came up with that. The scientific approach began in the 19th century. Very important to you, because this is what you guys are going to use in your master's thesis. Integrates the most important aspects of deductive and inductive reasoning, it differs from inductive reasoning because it uses hypotheses. More about that in just a second. So an example, you know, a couple of things come to mind that are relevant in what I'm doing right now, and this is not one of them. But let's say an education researcher wanted to gain information or knowledge about the use of a computer-based mathematics game on learning mathematics. The hypothesis would be related to the observed variables, which in this case would be the game, whether or not it was used, or whether it was used or not used. So you'd kind of set up in this situation probably a control experimental group, and obviously you would want to get some sort of baseline. This would probably enter possibly a covariate, or if you're using regression, you definitely want to put the students' their current math performance level, and then you'd want to see if there was an improvement. Something that I think is kind of interesting. A lot of us are doing this dual credit now. I wonder how effective dual credit is going to be. And when I think about it, I think there's no way it cannot be effective if it's carried out appropriately, and let me tell you why. Vincent Tinto, who was one of the experts in retention and attrition at the college level, said that the best predictor of success in a college class, is time on task. Well, if you think about the model that we currently use with the traditional lecture, you know, how much time on task do we really get when we're lecturing, and students are sitting there like these little obedient servants watching our every move. Yeah, some students really get into that and learn that way. Some students daydream, some students, you know, dwindle on their paper, some students go to sleep, some students just completely blank out. So how much time on task is there? Well, it depends on the student. Secondly, you give homework and they go home, work on homework. That's fine and dandy if students actually do the homework. So if you think about that entire model, how much time is spent on task? Well, arguably, for some students, not much. If you think about the dual credit, the way we're doing the flipped classroom approach, where in class we work on activities and then students go home and watch videos. So if you think about it, I think the reason this is going to be so successful is not because that it's some brilliant new thing in teaching mathematics, or teaching and learning in any subject actually, but I think it's going to be the fact that students, if they go through this model, they're going to spend more time on task. They're going to get the lectures outside of class, so that replaces the lectures we see in the classroom. And when students go home, you don't know whether they're going to do the homework or not, but when they come to your classroom and you do the activities, then you can kind of keep a gauge on that. So, you know, just food for thought. Guys, in other words, at the end of the day, the real purpose of scientific inquiry is to make sure nature hasn't tricked you into thinking that you know something when you actually don't know. You know, that's extremely important. Guys, in the scientific inquiry process, and of course you probably know what's going to happen. I'm going to give you a situation on an exam or homework assignment, and you're going to run through the 5 steps and tell me what you would think at each step. So the first step, identify the problem, realize the problem exists. I consider this to be the motivation for the study. Why is this study important? You know, what can it bring to the knowledge of the subject? So the problem may involve a question, it may involve a discrepancy, it may involve a gap in knowledge. The second part is to officially state the problem. The third is to formulate the hypotheses. We're going to do quantitative research, and because the reason is I don't know a lot about qualitative research, and we'll talk about that a little bit more in the next video. So formulating the hypotheses, for example, if we're running a multiple regression model and we have, let's just say, 3 predictors, well, we would formulate hypotheses about all of the predictors, and we would see which one, if any, or possibly all, you know, provide important information about what we're trying to predict. The fourth thing is predict the consequences. what do you think is going to happen? Typically when people go into research, they're very optimistic, and they think that the motivation for their study, that this dual credit flipped learning thing is the best thing since sliced bread. Well, they kind of think that the prediction of the consequences are going to be that, well, this is a good thing. The grades are going to increase. They're going to be better than we've seen in the past. So you predict the consequences. And finally, you carry out your test. Quantitatively, you carry out your analysis and state your results. Guys, we are going to be looking at education research, and probably a couple of the reasons that education research has become so important lately has to do with No Child Left Behind and scientific, or standards-based reform. Both of these are situations where they want to make improvements or changes based on valid research, and I call that scientifically based research. So education research has become the driving force in a couple of these, in these two reforms. Well, I lost my train of thought there. Had something really important to say, but you guys aren't going to get it because I was thinking about something else. So, questions that I want you to be able to answer after watching this video. What is the role of theory in scientific inquiry? What's the difference between inductive theory and deductive theory? What are the characteristics of a useful theory? And which of the following would contribute to theory development in education? Evidence that supports the hypothesis of a study, or evidence that refutes the hypothesis of a study? Guys, the answer to number one, what's the role of scientific inquiry? Well, theory integrates findings, summarizes information, and provides leads for new research. The answer to the second question, inductive theory serves to explain previous observations, while deductive theory is developed before extensive observations have been made. The answer to number three, explains the phenomena, is consistent with the observations, and stimulates new investigation. And the answer to number four, actually both of those are important. A lot of times people set up research and they formulate their hypotheses, and you think about how are we going to test hypotheses? Well, with p-values. We're going to test statistics and create p-values and make decisions. And people are so invested in their study, sometimes they fail to realize that even if you get a p-value greater than 0.05 and you fail to reject the null, you still have contributed to knowledge about the subject. You've found that whatever you have hypothesized to be predictive of or explain some phenomena in education doesn't exist. And you think, well, that's not good. I didn't prove anything. Well, actually, you kind of did. You proved that your model wasn't that maybe there's something else explaining the phenomena. Let's think about this. Let's think about the traditional classroom versus the flipped classroom. Let's say that we conduct a study and we get a p-value greater than 0.05, indicating that at the end of the day there's no real learning difference. I don't know how we do that. Maybe a common exam, or maybe examining grades. But there's no difference in learning for the traditional versus the flipped classroom. Well, is our study a wash? No. It provides a lot more knowledge about the comparison of traditional and flipped classroom. Guys, this is going to be a kind of a quick video. Under week 2 on Blackboard, where you guys access these videos, there's going to be an additional video, a suggested video under Khan Academy. I was going to go into more about inductive and deductive reasoning, and I pay attention to these folks because they're good. And they put up a sequence of inductive and deductive reasoning comparisons. So I'm going to encourage you to watch that. Never know when things might pop up from videos that I suggest that you watch. So guys, that's the end of the video. It's going to be a short one, but in addition to the video I want you to watch with Khan Academy, it gets us right around the 50 minutes. So take care.